Hello, so I'm Rohit Ghumare and I'm currently independent developer advocate. So currently also recognized as a Google developer expert for the Google Cloud. So today we are going to talk about what is sidecar-less service mesh and what is ambient mesh, what is istio and what do we do. So let's talk about who am I? So I'm developer advocate. I have been recognized as GD. I run my own podcast which is named as the Cloud Native Talks. It is for the people who are around cloud native DevOps and want to learn about the same. I sometimes speak about developer relations also. So I have been part of various committees like KeepUp, DevOps committee, developer relations committee. I run KCD, CNCF, and a lot of communities. So if you want to connect me, if you want to ask me doubt around the same, you can reach out to my these handles. So let's move forward. And as you can see, so common questions everyone is having like why actually service mesh is needed and what is actually the thing. So there are some challenges with the microservices. So as you can see, if you have multiple services, how you will interact with the same. You want to work on the services, you want to means like pass the connection from one end to another, from one endpoint to another endpoint. So how you will make that secure? Then there is a lot of problems like resiliency, timeouts, and communication failures. So this is some of the topics where I think service mesh is needed, but yeah, like you can do it by like with this traditional method also. So what actually is the problem? So it is really complex and a lot of things are there, right? And how you will control the traffic? It doesn't happen. These things doesn't happen in the traditional approach. So that's why Service Mesh was introduced. Service Mesh is nothing but a one programmable framework which allows you to observe the things, observe the integrations, and then secure your means transport of the packets from one endpoint to another. Then it connects the various microservices. So like you have different microservices across different jobs, applications in your cluster, or it can be in your application. So how you will do that thing. So that's why service mesh is there. So before service mesh, what happens? So there was like, let's take example, you have service A and service B, which is nothing but you have any web page, right? You want to transfer some some traffic from one service to another service. So you have to go by the traditional approach and you will directly do the same. But developers have to work on this thing in a manner like they have to work for the transaction of the services and traffic, everything they had to do. But they don't love that, right? Before service mesh, it was like they are working on the code as well as they are maintaining the business logic for it. So it was really not feasible, right? So that's why service mesh was introduced, like operations team, you do this thing and we will do this thing. So thing is like now developers don't want to focus or don't need to focus on the what actually is the business logic on your code. They just write their code. And other things will be managed by the service mesh. Service mesh will manage everything like whatever resources you want to add, whatever traffic you want to manage or something, then everything will be done by the service mesh. So there are some end goals for the service mesh, right? So like service discovery, load balancing. So service discovery, load balancing, which is like you have like lot of means like you have to scale lot of your applications through different servers and something. Our service mesh will help you that. So you will say Kubernetes is the same, but it is completely different. Then there is a secure service to service communication. Of course, there is mutual TLS connection. Then there is a traffic control, shaping, shifting. So whatever you transfer from one packet, one service to another, traffic will be managed accordingly. You can put new policies, intentions based access control. Then you have the traffic metric collection. You can observe the things, observability is present, as well as you can make your you can make your business resilient by putting lot of resilient process, right? You generally have seen that in the incident management and kind of a things, right? Then there is a API programmable interface, so which is nothing but you have the APIs to connect all of the gateways, ingress, and lot of things. So there are some platform goals with the same service mesh, as you can see. At the application level, routing, though there is like filtering transformation, which we talked about. Then observability side, you can collect the metrics, you can capture the traffic, you can work on it, you can work on the logs, you can observe things, you can introduce the new integrations in the observability. So everything is present by the anchor point, as well as resiliency is one of the main factor in the business, and it enables it by traffic resiliency, failover, high so you don't have to work, means like you don't have to wait for being your next job to be available. Yeah, it is will be done by the service mesh. Then zero trust security, which is one of the important part, right? So zero trust security is nothing but like you don't just send, right? You first authenticate everything and then you get the permission. So secure communication with the microservices, you manage the mutual TLS connection, then you manage the certificates, certificate rotations you do, you enforce the proper security policies, filters, then only it will go forward. Any doubts you can ask me anytime. So as you know, so what actually is the istio service mesh, right? So istio service mesh is like it has so whatever if your application is sitting outside of the cluster, is sending something, right? So it will captured by the gateway, and gateway will send it to the your this service A, service B. So in service, what happens? There is sidecar proxy, right? So sidecar proxy will take that resources, take that traffic and everything, and that will be means like whatever if application A wants to send some information to the application B, then it will go to the sidecar proxy, and sidecar proxy will send to the sidecar proxy of the application B, and application B will acknowledge that. But everything is managed by the person who is sitting outside, which is the istio control plane. And Kubernetes does this. Kubernetes sends the service discovery, mesh configuration, and stuff. So HTOD will be the only one who will collect the metrics. It will provide the configurations. It will generate the certificates, and what are metrics are generated will be done by the sidecar proxy. So what is actually the sidecar proxy? It is nothing but your envoy proxy, right? So whatever happens, service sends to the outbound traffic is going to the proxy, right? So that proxy is nothing but the envoy. So how Istio works today? So as you can see, there is a service A, service B, which we talked about. So every application pod is deployed with a proxy, which is Envoy proxy, right? And this entire thing is known as a data plane. So the proxy is the sidecar of our application. So all L4 or L7 traffic goes through the sidecar proxy only. L4, L7 is your layer 4 and layer 7 capabilities, right? So as we move forward, as you can see, Istio control plane. So as you can see, control plane is something which puts the policies, filters, proxies, everything. It generates the certificates, it keeps track of your entire service mesh, and it is the only one who will collect the metrics and work on the things, right? So control plane is separate from your data plane, but it is the only one who will do everything. So we already talked about this, and as you can see, istio sidecar model is like you have the resources in the application, right? So that is done by the envelope proxy, right? So, but it's really complex, like large deployments of the enterprise service mesh. As you can see, you have like one, like let's say your bar.solo.io wants to talk to the wine.solo.io. We'd have to go to the level egress, top level egress, then from your ingress of the istio service mesh to the going to the top level egress of the foo, then it going to the wine. It is like really complex structure. It looks easier at overview, but it is not. It is really complex. So, so there are a lot of challenges in the sidecar proxy: overhead cost, operational complexity, performance issues. So actually not a issues or something, but yeah, performance is a lot of it's like it is comparatively low, right? So whenever you are deploying any istio book, means like istio any application or something, I'm just taking the example of the bookinfo. sample deployment which anyone has done till now, right? If you know the issue. So you can see like one container is extra attached every time, which is sidecar, right? It is just increasing the lot of things like it is increasing your cost and lot of things. So there is some challenges which is operational complexity. As you can see, you have to move through the lot of things as I show you. Then application mesh aware, which is nothing but application is not aware of means like your service mesh is not aware about what is happening inside the applications. Another thing is like latency, like you have to go through the one application to the sidecar, then sidecar go to the another sidecar, and sidecar goes to the application too. So that increases the latency for sure. Then cost is in, of course, you have like lot of sidecars attached to the different pods, your containers, right? So of course it will take your cost for sure. So what is the future of service mesh? So future of service mesh always will happen around the data planes. So as you can see, data plane is where the innovation continues to happen. It is nothing but the extend in the data plane, which is Envoy. Then there is a WebAssembly. You can push HTTP and so first is your you can also do the configurations around the GraphQL and stuff, right? Another thing is like you optimize the data plane in the future, which is nothing but eBPF. You can do the server level code, right? Kernel level code. So introducing istio ambient mesh, it is new open source contribution launched last year by collaboration with the Solo and Google and lot of contributors around the world. So they are working really nice. As you can see, cost reduction happened, simplifying operations happened, then performance is improved. It also has a Rust-based configuration. So what actually it does, like it slices the layers, so you have like secure overlay and L7 processing layer. So whatever you want to do, you don't have to input all of the things. You can according to your need, you can configure the thing. So if you want the TCP routing, which tunneling, it will be provided by default. You just have to input new policies for the L7 things. So observability without istio sidecars is like whenever you have to scrap any metrics or something, you have to like go to the sidecars of your like you have the two ports, right? So and inside your node there is a two ports, and then it will have that containers, and so sidecar is the one who will provide the application metrics to the Prometheus, right? So, are we doing everything for that, right? Are we working really nice on that? So, as you can see, if we use HTML mesh, what happens? It directly provides the previously it was like istio proxy is the something which was Prometheus, right? So now you don't have to worry on the same. It will directly provide. Then what is actually the HTML mesh? It doesn't have any sidecars attached, so you have like previously you have the pod per proxy, right? Every pod has a one proxy. Now you have the proxy and for the entire node, right? So as you can see, sidecars are reduced, so your cost is reduced. Similarly, what is HTML ambient mesh? It reduces the cost directly, as I talked about. In your HTO sidecar data plane, you just have the one pod per proxy. You don't so previously you had the one pod per one proxy. Now it has like one proxy per node, which is like biggest thing you can do. One of the nice blog written by the Solo is like which talks about HTML embed mesh means what it means for your wallet. As you can see, it reduces the CPU time, it reduces the memory and lot of things, and it reduces it really vastly, right? As you move forward, then as you can see, there are a lot of advantages using the HTML mesh. It reduces the latency and what are the other things, right? Then if you talk about it reduces the cost, proxy per node it is, then you have the multi-tenant proxy which will help you to work on a lot of things around. If you have like come across the platform engineering, it is one of the really uh, really configured nowadays, and people talk it a lot. Then lightweight proxy L4 implementation. Then there is a simplifying operations is done by. So what happens? Anytime you are launching new something, means you have to attach any resource to your application or something. You have to start your pods in previous versions of the istio. But now it doesn't happen. Like istio embed mesh is like data plane which you can directly add to your configurations, so you don't have to worry on the restarting your pods. If you are attaching it directly, you don't have to restart it. It will You can directly run from that, so it makes lot of work easier, right? Then you will not have to face that downtimes and lot of things, right? Simplifying additional new application, then simplifying application updates, decoupling proxy, and yeah, L4, L7, right? So you can also use it for the acceleration of the using the eBPS, then zero trust security, what can be done in the future. Then you can see, yeah, it provides L4 matrix and mutual TLS. Similarly, you have right statement, right? So here you can introduce the eBPF in a manner like it is the one who will solve everything for you. Like you don't have to worry on the sidecar also. Sidecar can be replaced by the eBPF technology. So there are a lot of resources to learn about HTML mesh. You can go to these blogs and you can learn on the same. So one of the thing which I would like to discuss about what you can make a lot of things easier, which is like here. So let's say if you have if you want to talk from service A to service by doing some policy attachment, right, in the HTML mesh. So previously, what happens? If you have to attach that things to the sidecar proxy, then application will talk to the application view. So now it doesn't have that. It directly have the entire node has a one proxy, right? So that proxy will talk to the every applications of the thing. So how beautiful it is! Like one proxy is there, which is named as ztunnel. That ztunnel will talk to the application A, then application B, application B, anything, right? So it reduces your complexity, it reduces your cost, it also do lot of things for you. So you don't have to worry about the L4 things. Then it comes by default for the L4 capabilities. Comes by default for the mutual TLS. So another thing you can do is like L7, right? If you want L7 capabilities, you want to work on the failovers and lot of things, right? You just have to add a policy by doing the configuration. And once you do that, and you can directly work on the things you want to introduce something, you can do that. So all of these are available in like one of the workshop provided by this HTML and Mesh. You can go to the Solo Academy and you can learn about same. There are a lot of resources around the istio. And if you want to ask any doubts, you can connect me anytime. So thank you for connecting. I hope you learned a lot of things around the same. So thank you.